Hello, and welcome to the MIT SDM Systems Thinking webinar series. My name is Naomi Gutierrez, Communications Administrator for SDM, and I'm today's host. Thank you for joining us. Today's speaker is Bruce Cameron, Director of the System Architecture Group at MIT. Dr. Cameron has directed research projects for Amazon, Chevron, Sikorsky, Nokia, Caterpillar, and NASA. Dr. Cameron is also a co-founder of Technology Strategy Partners and has been a board member at 10 early-stage firms across consumer and online platforms. He is a past board member of the University of Toronto. Dr. Cameron's teaching in Sloan's executive education was tied for the highest-rated executive education program at MIT for several years. He is also a senior lecturer for the System Design and Management program. His talk today is titled "The Rise of MegaConstellations: Assessing Supply and Trends in Satellite Communications." If you have questions for Bruce, please enter them into the chat window at the side of the video. They will be addressed during the Q&A portion of this session. A recording of this presentation will be available online at the same address after today's session, and a link will be sent to all registrants. And Bruce, the floor is yours.
All right, thank you very much, Naomi. So we got a fun topic ahead of us today. This has been an area of research for me for the last decade, arguably. I come to this as a satellite person, not as a communications person, but it's been tremendous to see the level of interest, investment, technology development that's happened along these lines. And so I think there's some interesting results to share here. I'm going to share sort of my perspective on the market as it exists today, and I also want to talk a little bit about what are some of the technology trends. Obviously, I've got to put my SDM hat on for some of this. Diving right in, I think there are two big trends that have hit the SATCOM market, and one of them, as you may have heard, is that there's a tremendous number of new entrants into this market. SpaceX being the most commonly cited in the news, but there are several others. Now I'll give sort of an overview of who's entering, but clearly there's something of interest in this market. And then second, from a technology perspective, we have brand new, arguably, technology that is really going to change how these services are offered, in the sense that we used to put a beam over a whole continent. And now, with phased arrays and modern satellite technology, those beams are much, much smaller and potentially more targeted. And with that comes a tremendous amount of flexibility. Now, what we do with that is still an open question for operations, but I think that there's some interesting implications there as well. So that's kind of what I wanted to talk about in the scope of this. So starting with the first one, the four largest or best capitalized players in this are SpaceX, OneWeb, which recently merged with Eutelsat, Telesat, and Amazon. And the number of satellites that they propose to launch is staggering. So for comparison against these numbers, 4,000, 6,000, 3,000, et cetera, satellites, we as a species have only launched 9,000 satellites to date, roughly. And public information being what it is, we understand there's about 5,000 that are in orbit, all orbits, not just this orbit, prior to the start of SpaceX launching these. So, we are going to increase the number of satellites by an order of magnitude in this process, if all of these come to fruition. Now, that's an open question. Are they all going to survive in this market? But if we sort of project forward from today, that's what's on tap. Now, why are they so interested in launching these networks? So, from an underlying demand perspective, I think there's two ways to see this. One way is to see sort of what's the existing sort of organic growth of demand, and that's what's here on the chart. And what we've seen is the demand for essentially one-way video broadcasting is flat to down over time. I'm showing one projection. There are several. And the demand for data, notably bidirectional data going up and down, checking your email on a flight, watching a YouTube video on a cruise ship, is really the segment that's growing here. And what's interesting about this data is even though we have sort of law of large numbers, more users participating, what we see is that this data is actually becoming more bursty rather than smoother. And that will play into some operational challenges that these constellations are going to face. The other way to see this trend is to ask the question of like demand stimulation. If we were to build it, what new applications would come online? And I want to talk about that in part today. So this is part of what's driving interest in these new entrants. Looking at sort of disruptors versus incumbents here, you may or may not be familiar with the structure of the market, but there are several existing incumbents in the market. I'm listing them here. Inmarsat, Telesat, Intelsat, Eutelsat, SCS. Obviously, there's a pretty common naming convention here. Many of the existing communication satellites are all the way out in GEO, some 35,000 kilometers away. And notably, the architectural decision that many of the new players have made is low Earth orbit, 500 to 1,500 kilometers up. And so with that much closer orbit comes both challenges and opportunities. The big benefit of being in low Earth orbit is you're closer. The latency of the signal, time of flight, is much smaller. And so the speed's possible and the latency on those services comes down, which is great. The downside is orbital mechanics, which essentially causes these satellites to rotate around the Earth a lot faster. When you're out at geostationary orbit, as the incumbents are, you can sit over one place in the world 24 hours a day, beam television down. By contrast, when you're in low Earth orbit, you're going around every 60 to 90 minutes. You are not sitting over one location. And so if you take a user, obviously in a static location looking up, they need a lot of satellites going around in order to have continuous coverage. And that's part of what drives the architecture of these constellations being so prolific with the number of satellites. There's been quite a bit of coverage of this in the news. So I just thought I'd hit a couple of the highlights if you don't track this market. So for those of you out there with mega yachts and regular yachts, good news is Starlink launched a new service for dedicated to boats. I don't know how large that market is globally, but I would expect that they're going to price accordingly. In other news, Starlink has also announced that they intend for their next generation of satellites to also offer mobile phone service, which is going to be really interesting and is part of the legacy of this market from the early 2000s when there was a large sort of phone constellation proposed with Iridium and Globalstar. We've seen tons of merger activity in this market. So Eutelsat, one of the incumbents, merged with OneWeb, formerly in bankruptcy, then bought out of bankruptcy by the British government. Now this merger. Viasat and Inmarsat announced late last year that they intend to merge. I believe that merger has not yet closed. There were murmurs in the news about SES and Intelsat, two incumbents considering merging. Viasat, I think just last week, announced that they intend to sell their defense communications business, which is joint with L3Harris. Fascinating numbers here. They're arguably selling 2/3 of their market cap. Obviously, that's not quite the way the math works, but $2 billion sales price, market cap of $3 billion, and pretty high net debt ratio for that company. So, quite a bit of news going on in the market today. And, one way to read that news is the incumbents are consolidating under the expectation of increased competition from these players. Another way to see this is the proposed constellations are dramatically going to expand the amount of supply for this market, and with that comes a lot of price pressure. So how do we respond to price pressure? Consolidation is one possible response to price pressure. Now, I've been using this language proposed. Many of you know that Starlink is already in operation. I think it's worth talking about sort of what's the state of the game for these players. Obviously, the incumbents are all operating with their existing customers today. So SpaceX has launched some 70% of their initial proposed constellation of some 4,000 satellites. So they've, round numbers, 3,100 satellites last I checked. Because this is a direct-to-consumer business, they have some 7,000 subscribers. That is relatively novel in the satellite business in the sense that typically there's a number of distribution layers, meaning the operators do not always sell direct to their end user. They sell to packagers in the meantime. OneWeb, by contrast, has launched some 7% of their proposed, I want to say it was 428, don't quote me on the math. And Telesat has existing sort of old school communication satellites in orbit, but does not have any of their proposed 1,671 satellites up yet, still in design, if I remember right. And Amazon's been pretty quiet about this, but very obvious that they do not yet have any satellites in orbit. So that's sort of where we are for the new entrants. And one of the questions that's of interest to me is, will the market support all of them? One of the classic failures of market entry is taking the state of the market today into account from your business plan, but not necessarily accounting for all of the capacity that will come online before you come online. And that's been shown to be the case from a real estate perspective. Condo developers often plan based on what the vacancy rate is today, not what the vacancy rate will be 5 years from now when the apartment block is finished, given that vacancy today plus minus capacity coming in over the next 5 years. So you might be able to judge from the graphics that the constellation design is actually different for these different players. You can sort of see SpaceX is quite a bit thinner around the top, as am I, in some sense, around the pole, as compared with the Telesat proposed constellation and the OneWeb constellation. You can also see that some of the choice of planes are different. What you can't tell from these graphics is that the altitudes of these constellations are different. And so in that sense, it's interesting that they've made some set of technical decisions which imply service to different areas of demand, different areas of the globe. So in a lot of this work, I'm going to be citing from a paper written with a number of co-authors here at MIT, which I put on the title slide, among them Niels Packler, one of my current PhD students, Inigo Del Portillo, a former PhD student now at Google, and others. This work is not exclusively my own work. I'm fortunate to have a research group to work with in this context. And what we see from this plot is that there's quite a difference in, among other things, the coverage of high latitudes. For reference, on the sort of middle of the chart here, I'm showing the distribution of the world's population relative to latitude. So you can see here that some constellations have more satellites in line of sight at higher orbits and others do not. Now, one of the things that makes this a particularly challenging area to work in is none of the math is linear for this. You can't quite say, if you double the number of satellites, do I have double the global capacity? There's a lot of modeling that goes on in the background to try and figure out the orbital dynamics. What does that imply for coverage? There are a whole bunch of choices yet to be made here. Among them, what are the gateway locations for new constellations, which in turn plays into this. This is a very nonlinear problem, which is, among others, why we've had so much fun with it from an MIT perspective in modeling. Now, thinking about who is connected, who's this market, who are these things built for, I think is a really interesting question. So what I'm showing here is results from a paper that I had written with a couple of collaborators here, showing what fraction of the world's population has reliable internet access. And the short answer is about half. And the math sort of breaks out that 50% of us have reliable access to the internet. A further 35% have intermittent access, and some, round numbers, 15% has really no access at all. And to me, that's a tremendous social opportunity, given all of the research that supports how connectivity to the internet is a tremendous driver of economic growth at a regional and a national level. And so one of the questions is, with these new constellations, do we have opportunities to serve and bring online really 4 billion people who don't have it today? So this is kind of a discussion that we could have. I don't know if you've seen this meme before. Famous for rhinos are out of shape unicorns and cereal is really soup. So we could have a discussion about this. I'd certainly be interested in the chat to hear your comments towards the end here. I'm welcome any questions that you guys have about the talk, but I'd also welcome your comments on where do we think this particular issue lands. So as we've looked at this, the central challenge of this question is a question of affordability to me. And when we look at this 50% of the world's population, we're talking about the poorest 50% of the population. And the cruel math on this issue is that that 50% is only 10% of the world's wealth. So, if you want to think about it like this, there are several barriers to global connectivity. And we could ask the question of, is it infrastructure, the unavailability of infrastructure? Is it a question of affordability? Is it a question of relevance? Do I understand what this would mean for us? Or is it a question of readiness, meaning digital skills, literacy, etc.? And our analysis of this issue suggests that the central issue is affordability. Another way to say that, one of our past research results was to bring some of these communities online, you would have to decrease the price by a factor of 100. So 1% of the existing price rather than the current price, in order to bring a substantial fraction of those not online today back online. So, recasting this issue, you could ask the question of could spending on satellite constellations in the future constitute a form of aid? Today, many countries send money overseas, but many countries also send goods in kind overseas. As one example of that, my home country, Canada, I don't know if you can hear my Canadian accent, buys a tremendous amount of wheat and grain to support prices in our jurisdictions, and then the government ends up sending that wheat and grain as food aid overseas rather than just dollars. So there was quite a bit of news around, Starlink, SpaceX trying to capitalize on positive news coverage of Starlink being used in the Ukraine to support downed communications infrastructure in the conflict there. They went back and forth. This is an article from the from the Washington Post, where it turned out that it was actually U.S. government had been paying for this. It wasn't Starlink offering services in kind. They've kind of gone back and forth on that issue. It's not exactly clear to me which way that landed. If you are curious, there's a great website. I haven't linked to it here, but you can find it, that actually shows where the Starlink satellites are in real time. And so one way to do it is to pull up a map of the Ukraine, and you can see sort of how many are in line of sight at that at any given moment. So looking sort of more broadly at this issue, then I think what that suggests, if we put a commercial hat on, is that the commercial opportunity against which several of these companies are investing, right? Not governments, companies, is that the commercial opportunity of connecting 4 billion people, while a tremendous social issue, is not a tremendous business opportunity. But we might think about continuity of internet access for existing users, or new sensors, new devices coming online. Think, remote water valve that is in an unattended location. Could that have internet by putting a terminal next to it and giving status? Yes, it could. How valuable would that be? What would we be willing to pay for that is a whole other question. Just to close on the sort of 4 billion people, one of the elements that I find really quite interesting here is when you look at the orbital mechanics, as I very, very quickly explained, to provide continuity of coverage for one location on the globe, when you're in low Earth orbit, because these satellites are going around every 90 minutes, you need quite a large number of satellites to provide continuous coverage. You can think of that as a lot of satellites in one plane, or you can think of that as several planes. Planes meaning an angle at which one of these satellites is going around the world. I'm trying to sort of stay out of the details of the orbital mechanics here. But one of the things that's really interesting about this constellation design is that for a substantial fraction of the time, your satellites are not above your destination population. So if you were to think about this just for a moment, if we thought about this as we're investing in this constellation for existing users in North America and Europe to have internet connectivity in places where they do not today. Let's just say that that's why they were investing. You might well be able to underwrite this constellation on the basis of some future demand, but then you sort of get connectivity in Africa and other locations for free because these satellites are going around and around and around. Now, some choices you can make can help you use your global fleet of satellites just for your destination market, if you were interested in that. Among other things, being able to talk across the satellites, meaning beam communications from one satellite to another satellite to get down, is one way to essentially extend the coverage over a given market. But arguably, there's, the capacity of the network is sort of lost when you're over the rest of the world. And so I think that's just one of the really interesting dynamics here. Again, I don't see these folks providing service for free. These are all for-profit companies. But I think it raises really interesting opportunities from an aid and from a global development perspective. All right. So one way to think about these sort of future opportunities for existing users extending coverage is to think about sort of where do we lack connectivity today? And just as a fun exercise, these are some of the highlights from my history of connectivity. Last time I went without cell coverage or internet service for more than a couple of days was a long time ago. It was 2004. That being said, there's lots of sort of bridged attempts that I made. I used a Bluetooth from my BlackBerry when I was on business travel, whether that was in a cab or taxiing on the runway or other. Not as much need to do that anymore, and certainly much more seamless. I used to carry a spare cell phone to put another chip in. Now that's made quite a bit easier. And we have new use cases, obviously. I never used to have the roaming plans on when I would travel internationally, but Google Translate being the miracle that it is, when I was in Japan a couple of years ago, being able to see a live view of the menu as translated was tremendously useful. So again, these are my consumer connectivity opportunities, if you want to think about it that way. Separately, we could put a business hat on and say, from a business perspective, when are businesses in a place without connectivity, and what opportunities does that suggest? So returning to the new entrance here, this is sort of the money chart in a sense. This is hopefully a simple presentation of a tremendous amount of complex work. This was a bunch of work that we did at MIT in an effort to try and understand what is the true capacity of these new proposed constellations. For background, when you launch satellites and when you operate communication satellites, you must get permission to do so. You have to have an allocated fraction of the spectrum. And in order to get that allocated fraction, you don't just get to buy it, you have to apply for it. And in this case, several of these are regulated by the US government, not all of them, obviously. Telesat is in Canada, OneWeb now. I presume they're going to move their headquarters to France, but I don't know that for a fact. SpaceX and Amazon here are obviously regulated by the FCC as the domestic entity for the International Telecommunications Union. So long story short, you have to acquire this bandwidth, and with that acquisition, you disclose to the government what your plans are, and that's tremendously useful to us from an MIT perspective, from a research perspective, because that gives us some common baseline of information that we can plug into a model to try and assess what capacity exists. Now, all of these players have their own statements about how much capacity they think, but what I'm going to show you here is taking sort of the facts of their case and putting them through an apples to apples model at MIT to try and sort of level the playing field and say, if you have this many satellites and if they are in these orbits, et cetera, using a bunch of assumptions, which we declare in the paper there, that would produce this much capacity. One of the big assumptions I will note is your assumed distribution of demand around the world, who is buying, influences how much capacity is available. Said otherwise, we're not reflecting the time here when this when these satellites are over a section of the Pacific that nobody is in. This is capacity that could be used, capacity where demand exists. So what you can see here is, there are certainly differences between the constellations on their, absolute capacity. You can see on the y-axis, I'm plotting capacity in terabits. And on the x-axis, what we've done is we're actually reflecting the number of gateway antennas that might be possible. So the gateway, if you want to think about it, the user terminal is where you are, and the gateway is how the satellite talks to the internet. So the signal goes, one way of saying it, from me, the user, up to the satellite, from the satellite down to the gateway, from the gateway to the internet. So we don't know where all of these gateways are going to be for new constellations, so we had to make assumptions. And if you turn the number of gateways up, you get more capacity. The other thing that's being plotted here is whether you have inter-satellite links, the ability to talk from one satellite directly to another satellite rather than just to the ground. And that's a hard problem. If you imagine, I had a colleague who used to talk about this as trying to shine a laser at a barn door where the barn door is moving at thousands of kilometers an hour, and where you are, where you're not in the easiest place to shine that light. There are a lot of difficulties associated with that challenge. And for the players that in their initial filings expressed that they were possibly going to have intersatellite links, we've shown the difference between no intersatellite link in purple versus if they had an intersatellite link, how much that would increase the capacity. And you can see in particular for Amazon, that's quite a differentiator. SpaceX, not shown here, has discussed having inter-satellite links, and I think they've also trialed it in the network with a couple of the satellites. These are their initial operating capability. The paper also discusses a separate filing that they produce for their final operating capability. So, all else equal, these are relatively equal capacities. If you look, the x-axes for these four plots are the same. There are lots of interesting sort of technical choices that each of these companies made, trying to essentially target their service to markets that were of interest to them. Relative to the capacity that we have on the internet, 1 terabyte per second is only about 1% of the world's data rate. So if you sort of squint at these charts and it looks like several of these players might add up to 20 terabits if all four of them were to come online. We're only talking about 2% of the world's internet speed or capacity. But in other terms, relative to a 2017 estimate, this is about 100x growth in the supply of internet from space. That's very exciting. Now, what does this mean if you're an incumbent? Well, there's a whole bunch more supply coming online. And one of the things that I think all the incumbents are trying to figure out is this supply primarily going to be targeting the existing customers in the market, be they military customers or airlines or cruise ships or other? Or is this primarily targeting a whole new population that's not really covered today? And it's a little bit of both, but I think the merger activity I showed earlier suggests that there's pretty significant concern. Now, some of you may be watching this and asking the question, is there some deja vu here? So this is a chart from former MIT professor who was also the vice president of one of the prior attempts to put a large satellite constellation in orbit. So Joel Schindel was the VP of engineering, I believe, for Globalstar. In the 2000s, you may remember, there were two big proposals and significant investments put forward to put constellations up. And, phone access in remote areas was one of the big use cases for this. The initial outlook was exceedingly positive, as you can see from some of Joel's statements on the left-hand side. Over time, they did in fact launch a bunch of satellites. Iridium spent some $7 billion. Globalstar spent about $4 billion. And really, the market yawned. It turns out that the service was, as delivered, was not a hit. There are various reasons that people cite for that, one of which being the handsets were ungainly, sort of like a two-handed cell phone with patchy quality. I think also some of the demand projections were particularly rosy. Remember, this was early internet boom, but this was not widespread use as we know it today of data. And both of these firms went into bankruptcy. Now they both came out. There are still Iridium birds up there that are operating. They've been transacted a couple of times since bankruptcy, but this was not something you would have wanted to invest in. Now, one of the other dynamics that's at play in this market is if you look at these four players, two of them happen to have billionaires attached. In fact, two of the richest guys in the world. So if you're Telesat or OneWeb, you have to be looking at this from the question of, like, is this discretionary spending? Is this fun money by these two, where they're not necessarily looking to achieve a return on an investment that matches the capital structure of the firm. If we take a sort of intermediate hypothesis there, do these two potentially have longer term return on investment time horizons and a greater willingness to take investment and losses in the near term? Potentially. Certainly don't know either of these two and can't speak for their motivations. But if you're an incumbent or if you're one of the other players, on what merits is this investment being evaluated is a big question that I would have. Now, I said there were two trends, and I want to spend a little bit of time on this sort of second trend about the technology that's available here. Phased arrays as the really big change means that we are able to compose much tighter beams, and we are able to move those beams. I've been glossing over this technology in the sort of talk today. This is not necessarily proposed equally in all of those constellations. They're making various adaptations to this. And similarly, the incumbents are also looking at some intermediate orbits and smaller constellations in partial response to this. So one of the sort of fascinating things about the way that satellite communications are contracted today is they tend to be contracted at a service level for a data rate. So you don't tend to buy 50 gigabits, you tend to buy 10 megabits per second. And you tend to buy that 24 hours a day, 7 days a week, regardless of your usage. So on this chart, your usage may vary, and the agreement specifies that the operator has to have that data rate available whenever you need it. Now, one of the reasons that exists today is for many areas, communication satellites have been a provider of last resort. If I had any other way to do this, I would have done it. This is expensive. This is, relatively speaking, low performance compared to a fiber optic line. This is the provider of last resort, and so those people who are buying want to make sure that that is available, and the market knows that, and I think that's reflected in this contract structure. But if we think about what the opportunity here is, from my perspective, the opportunity is tremendous to sort of more closely match the services as demanded and free up a ton of resources in the process. This is the equivalent, if you will, of overbooking on an airline seat. We make use of probability and projections about when people will use the service. We carry some sort of margin of error, and then we statistically offer more than what we have to recognize the fact that not everybody is going to use the maximum all the time. And this has been the subject of a tremendous amount of research for us at MIT, because to me, this feels like there's a lot of unused capacity here. And so, there's an obvious question, which is, wouldn't it be great to just have lower resource consumption? But the reality is the operating costs of a satellite network are not so big. It's more the capital cost of putting it up there. And then there's sort of a non-obvious question of, like, if we could do that, how would that translate to an increase in revenue? Could we overbook in the long term by just selling more customers? Could we overbook in the short term by offering something like a spot market? And this question is very much tied up in how we operate these constellations today. To exaggerate the problem a little, we are used to this idea of putting a beam over a continent. It's a fairly static representation of service. And it's actually, surprisingly, a fairly manual operation. We have sort of plans for, we're going to put a beam here at this time. Is that approved? Yes, it is. No, it's not. So with this increase in the number of satellites and potentially also increase in the number of actual consumers, there's a question about, could we operate more autonomously, which I think is very possible here. Second question, could we find efficiencies with this automation? And then third question being sort of, how would we translate that to an increase in revenue? So what we have been proposing from an MIT perspective is a sort of idea around dynamic resource management, where we host a model of the world and a model of the satellites, and we do a bunch of math in the background to figure out how we allocate our capacity more closely to what is demanded. And what that involves is figuring out where the beams point, figuring out what satellites it's going to be routed over, figuring out what gateways it's going to be routed over, and then at the end of the day, assigning specific frequencies, a subset of what we own as a band to this particular user, and then also assigning power to that link so that the link closes. Right? I need to be able to project enough power such that it can be received in both directions. So some of the complexities of operating that are, figuring out for each beam what the, which resource group, which beam channels, which polarization for uplink and downlink, while respecting a ton of constraints that exist here, because there's lots of potential, among other things, for interference. Two people talking on the same line at the same time. And from our perspective, we're trying to frame this, if you will, as an integer program, as an optimization to figure out what allocation of frequency plans would minimize power consumption, or you could also think about optimizing against other objective functions. So we've published quite a bit in this area. I'm going to link at the end of the presentation to some of those plans and some of the public journal articles that we have written. The initial results on this suggest that significant gains are possible if we were able to do this. Reducing the power required by about a third, and serving new demand, or if you want to think about it as currently unmet demand, we are reducing the amount of unmet demand by being more efficient with these services. So that's really the scope that I wanted to cover in the presentation. All of the papers that I have linked to in this talk are available on the group website, systemarchitect.mit.edu. Some of the ones that I've listed are here, and it's funny. One of my grad students wrote me yesterday to say, "You're living in the past. You don't have a QR code for our link. You should do that." And he kindly sent me that QR code, and so here we are. I'm showing it on the slide. So Naomi, I don't know how many questions and comments we have, but I'd be happy to take some for the next couple of minutes.
Yes, absolutely. First of all, thank you for a great talk. It's definitely a topic I'm aware of, but don't know a ton about, so I was glad to learn more. There's been some questions and discussions in the chat about the interoperability between the constellations, as far as whether standards appear to be emerging. Don Small in particular cited VITA 49.2 for digital IF/baseband packets, or CCSDS-SLE. I hope I got all that right. And just general questions about Sridhar Sadasivan also asked about architectural issues, business or political issues that players may not choose or can't have interoperability or inter-satellite communications.
Yeah. Okay, so let me come back. I'll ask you to remind me of Sridhar's question, but let me answer the first one. Yes, the reality is there's no interoperability between these, and that's in part because each of the providers has their own protocol. I don't mean that in the sense of process, but like a communications protocol by which they encode the information up and down. That means that we have tremendous duplication of infrastructure. And some duplication of infrastructure is good in the sense of, boy, I really wish that my home was served by more than Comcast copper lines. Wouldn't it be great if Verizon ran a physical fiber line to my house? I'd be okay with some price adjustments if they were to do that. But, do we need 4? Do we need 10? Do we need 20 different versions of this constellation is kind of an appropriate policy question to ask, right? That's not really a commercial question, that's a policy question. So I was on a panel a couple of months ago with actually a gentleman from alum from MIT Aero, who is hoping to help stratify this market. They were hoping to develop a common protocol and insert themselves in some sense as a layer in this market by which the constellation owners would sort of manage the hardware, but the software, if you will, would exist to communicate between them. And that really doesn't exist today as I have seen it. I'll be the first to say there's so much about this market and this technology that I do not know. So it's not to say that it's not out there, but yeah, there are some pretty large systemic challenges about sort of power balance and co-investment that would have to be figured if this market were to tip towards standards. Just for interest, the time required to develop standards is enormous. Not because it's technically difficult in any way, but because of the implied power balance that comes with it. So if you go back and look at like how long did it take for actors in the US to agree on thread pitches or like plumbing fittings, from memory it's like 30 years that they worked on that. And certainly we've had satellites in orbit for 30 years, but that has not emerged here. And one of the ways to sort of do that math is you have to think about the likelihood of somebody adopting a new standard is really a function of their cost to move from their existing operations to the new standard, because you have to assume that almost everybody is not compliant with the standard today. So it's a cost, and then it's a strategic evaluation of how much benefit that one player who is compliant with the standard is going to have. And that, to me, simple equation gives you a sense of how difficult it is to get standard adoption. Another problem or sort of wrinkle in this is once you put these birds up, they're up. And in many cases, elements of that protocol are hard-coded onto the satellite. And so you don't have as easy access to changing this over time. You're talking about renewal of the constellations. So hopefully I answered the first question. Would you remind me, there was a second question about sort of jurisdictions and political questions here.
Sure, that was from Sridhar asking about architectural issues and business/political issues that the players will not choose or cannot have intersat comms.
Yeah. So separate from what we just discussed, there's all kinds of like national issues that come with this as well. So whether that's sort of bands that you can't operate in because they cause interference, or whether that's rights that they have purchased and not purchased. To empathize for a moment with the satellite operators, they face a tremendous number of local constraints that historically have been pretty hard to manage. I think interference is really the big one that we've been working on from an MIT perspective, but I'm very aware that there's a whole bunch of other national constraints that exist on this. I'll leave it at that for now. But suffice to say, this is a hard problem.
Absolutely. We did have a couple of other comments from Conrad and Niradka and Akshit Singla mentioning the difficulty of interconnecting different shells at different altitudes and inclinations, which again goes to just concrete problems of the physical world, much like you can't just send someone up there with a screwdriver to open the panel on every satellite. And Akshit also pointing out this could be a great reason to have intermediaries that are designed for interoperability, much like you were describing the alumni of AeroAstro working towards, but there are always multiple challenges going into it. Akshay also had a question about the dark fiber demand he imagines could be supplemented with the extra resource availability. Certain use cases like maintenance and OS updates could be flexible on timings. And I'm curious about your thoughts on that.
Yeah, so for interest, the first research project that I did on this in this area was with NASA. So NASA operates 3 relay satellites. That's different from what we're talking about here in a sense. What NASA uses their 3 satellites, which are part of the TDRS network, that's an acronym, is to take data that's on board Earth observation satellites, like science satellites, and bring it down, because those science satellites can't always see the gateway from where they are, and so they use these relays as relays. It's in the name. And anyways, we got engaged with NASA on this because at the time, NASA said, we put these things up. They are monolithic satellites. They cost about $300 million, then dollars. This is 10 years ago, to put up. And the equivalent commercial satellite that would do the same thing is only about $100 million. And so NASA sort of asked us this research question, like, have we just shot ourselves in the foot by over-defining the problem? Like, what's the difference here? And you want to think about these monolithic satellites as like a school bus up in space. Pretty expensive. So what we did in that process was we tried to survey all of the users or representatives of the users to understand what kind of service do you need and what might that imply about the architecture that you would pick. And what was hilarious was there were very different postures from the different scientists about how quickly they needed their data and how much data they needed. Some of them had very legitimate arguments, like, I'm watching sunspots, and if we see a sunspot, like, we need that data to get down to the ground because it's a risk. And so like latency requirements are super tight. And we had others who were basically saying, like, I want it now. And we sort of asked, like, how quickly do you need it? Like, is 24 hours good enough? Or could we schedule the network such that you got it in a week? And they gave sort of various kind of hand-waving arguments about, like, no, I want it now, but I don't have a good reason. And then we had all sorts of other people who said, yeah, you want to deliver it next month to, like, help smooth capacity? That would be fine with me. So that was a very small community that we were able to do that with. And this is not a small community. So yes, you could imagine, to Akshit's point, moving different types of comms around through the day to make use of capacity when the network wasn't tight. And that's equivalently what we do with diurnal pricing in the power market. Many of you live in jurisdictions, I do not, where power is cheaper at night. And so you have an incentive to, like, run the hot water heater right before 6 a.m. rather than from 6 a.m. to 7 a.m. And you could imagine some playing around with some pricing in this market in order to share information about when the network is busy, such that people would have a reason and some incentive to move their use of the comms. That only goes so far in terms of your ability to signal these users and whether these users will actually modify their behavior accordingly, right? In the case of my power usage, some elements of my power usage are discretionary. In theory, yeah, I could make a decision about when I have a shower, but some elements are not. I'm not going to keep the lights off from 6 p.m. to 8 p.m. because the power is expensive. I'm going to have the lights on because I'm sitting here in the dark otherwise. So you could imagine trying to sort of communicate that to users here, but that would require quite a bit of market coordination. One of the other areas of research that we have been working on quite intensively, one of my graduate students, Skylar Eiskowitz, along with a world-renowned expert in what some of you might know as dynamic pricing, but we actually know it at MIT as resource management, or revenue management, or yield management, goes by a bunch of different names. Peter Belababa on the faculty here at MIT have been working around sort of what kind of pricing scheme could we imagine that would reflect some of this in the satellite market?
Yeah, definitely a lot to be considered there. Looping back to an earlier question, I think you may have addressed this a little bit, but David Bernstein was asking, in the 90s, the build out of cell phone networks killed satellite phone constellations. Will 5G build out do the same to these constellations? And we also had a comment from Sridhar again that gaps in the coverage are real now. And Jackie Cotain adding that 5G may also affect the adoption of IoT solutions in remote areas. So maybe satellite IoT has an opportunity. So this is kind of a couple of questions together, but I think they're related.
Yeah. Yeah, I think, if we look at this slide here about sort of what are the opportunities, 5G specifically, I'm not too worried about in this sense. Again, I'm not an operator, I'm a researcher, so like I watch this market with interest, but I don't have a dog in the hunt. But I'm not too worried about that in the sense that a lot of the users who we think about sort of continuity or new use cases don't have internet access today. It's not a question of the speed at which it's offered. Now, if you look at the Rural Opportunities Development Fund, which is where SpaceX actually got $1 billion from the US government in return for offering service to folks that only had dial-up or had no access in the US. Very industrialized country like the US, hard to imagine, but the reality is, yeah, there's actually quite a population in the US that has low speeds or poor connectivity today. But to me, a lot of the opportunities are in this sort of blue category of, the darker blue category of like new use cases that we haven't imagined today, and areas where even if 5G rollout proceeds as planned and proceeds as fast as projected, you're not in scope for that 5G rollout. And that's a good thing, because in the satellite industry, one of the hardest areas to serve is a city. In a city, you have a tremendous amount of users in a densely packed space. You need huge bandwidth, huge fraction of the spectrum to be able to offer service without interference. Whereas when you have low population density, you benefit from that. I can reuse the elements of the spectrum that I have in creative ways across rural users if they're not close to each other. So I expect that the use cases we're going to see for this are not the same as the use cases that people have for 5G. Now, I could be wrong, but that's my opinion.
Makes sense. I think there's always so many players that it's hard to give a hard and fast answer. So we are coming up right to 1 o'clock. So I think that's all the time that we have. Bruce, thank you so much for sharing your time with us. I believe your contact information is on the System Architecture Group webpage. So if people would like to follow up with more questions, they can reach you there. To our audience, thank you very much for attending this webinar. Again, the presentation recording will be available online after this session if you'd like to review it. And we hope you'll join us in November for the next Systems Thinking webinar. Thank you once again to Bruce Cameron for speaking today. And on behalf of the System Design and Management Program, thank you all for joining us.